back in. Hello again, this is Fire Emerald, back with another redstone, amazing redstone tutorial. And today I'm showing off infinite storage in vanilla Minecraft. Not item storage, data storage. Primarily integer numbers, although strings can be stored in instances themselves, although it is preferred otherwise. As you can see here, I have this board thing here. It's my interface. Right now it's a very simple interface. It just allows you to move things around and view what you have. So you can see up here, these are numbered 1 through 30, and you can change boxes. Everything's boxed, which is just an easy way of putting it. I could have used packs or clusters. I just use box because it's easy. It's easy to remember, and it's the shortest one, making it easy to implement and remember and stuff. So you can see I have 2 boxes. That's because box 1 has some stuff in it. There's always an empty box available at the index, I guess you would call that, after the highest occupied index. Now these can be moved around by simply right-clicking a sign and right-clicking another sign. It's near seamless. There's only at most, possibly a 0.2 second delay. If you saw that was these signs all being reset at once. It does that because it's the easiest thing to do. Because they all have to reset at once when you switch boxes. And not only can these be transferred inside this... There we go. But they can also be transferred between boxes. And as proof of the fact that there's always an empty box, now we have a box 3. It will loop around if you click on those. Now you can switch these two. You can also add more to it, which has not been implemented as an interface yet. But if I do this, I always hate that. Oops. There we go. If I put another one there and then set some variables. Slot. And box. And update this. Currently ready to switch in the box. There you go. It's shown up on the board. Can be interacted with just like any of the others. And one thing you can also do is have multiple ones with the same name. Completely supported. You can't really tell anything happening there, but they actually are being switched. So that's enough of that. If this was all you were wanting to watch, you can end the video now. I'm about to get messy and show you the gruesome details, which aren't really gruesome. Okay. We'll ignore this for now because this was completely built after I had all of this done. All this does is handle the transferring that, and we'll get to that soon. The way this works, all of these... Goodness, I could have just destroyed my map there. Then now I won't destroy the map. All of these are just to handle switching boxes. The real magic happens here and here, where this is just 2 clocks. These 2 are used to identify the current ones that should be in the box you're setting. It just, for each one of those, it copies one of their variable box, in this case, to a temporary holding spot called box different. Now, I had to test this first, but as it turns out, even if there are multiple of the same entity in the same exact coordinate, if you execute a command by one of those entities, through one of those entities, and use an @e, c equals 1, type equals whatever that entity type is, it will target the entity executing the command. Never fails. So I exploited that to allow me to copy, well, not really exploited that, I used that to allow it to copy a variable. Something that would be a very tedious process otherwise, and would not be instant. Then you subtract your current box, which is what the box the player is looking at. You subtract that from that. Only those that have a resulting value of 0 are on the box you want. So, when the sign is set, it tests for ones with the same, with the box difference of 0 and the slot, whatever the slot number for that one is. And the sign will display the name. And if there is none, it will just display blank. Now for handling the moving backwards between boxes, it's simpler than moving forwards by 1 command block. You start off by, of course, removing 1 from your box, and adding 1 to your zombie. Which seems weird at first, but it actually makes sense because you want to make sure that if you go back to 0, that it loops back around to 1 above the highest one. And the next thing is used to take whatever the box is. If you have it below 0, at or below 0, it changes to whatever the highest box value of any of the zombies are. That was the purpose of adding 1 to them. Then finally, you subtract 1 again from the zombies to put them back to the original thing. You fill that to update all of this. Actually, yeah. And this just clears this side. Now to go forward 1, you have to set a temporary variable. In this case, I call it loop. And I remove 1 from the box difference of those, again, to allow you to be able to go 1 higher. And you add 1 to close to yourself. Then this will set your loop to 0 if there are any at your current box number now. Hang on, yeah. Or actually, at the previous one. Meaning you should not loop. And then if the loop is still 1, meaning you should loop, it just sets it back to 1. This. Oh yeah, this right here is the same as that. And this is the same as that. It just clears it. More complicated by just 1 command block. Now over here, we have all the transference. This in itself is over 20 command blocks. This was just 50. Which I know people are going to, that's a lot of command blocks, but it's really not, considering how much stuff this actually does. for you. I'm not going to go into too much detail on this one. I'm just going to explain the states it handles. It handles 4 states, not including transitions between states. The first state would be if you clicked on a sign that was representing an unstored slot, in which case it discards everything and acts as if that sign hadn't been clicked at all. Your second state is if you do manage to click on, if you clicked on a sign that did have something stored, but this would also require that it was cleared previously, so it's technically your first click. Now your second 2 states only occur if you've already done that second state, and they are considered second clicks, after which there's going to be another first click. The first second click would be if you clicked on an unoccupied space, in which case it simply moves that there and then moves and then updates this display. Now, the final state, and this was one of the most complicated, even though it really wasn't complicated for me because I've done stuff like this before, is if you clicked if you clicked on another occupied space, in which case it moves 1, it actually copies its location to a temp space, then loads that location that just got copied to the other one. I mean, not to the other one. The other one copies its location to the one that just had its location copied, and then the copied location is set to that one, effectively switching them. And then it updates the display. And you end up with this. Now the way that works, without needing a clock, is with a sign, you can actually execute 4 commands in a specific order at once, using the run. The only thing is, the person who right-clicks the sign must have permission to use commands, unless you are using commands that don't require permission. But it goes in order of the run command. For any of you who don't know about JSON, you won't understand this, but it uses a run command raw JSON click event. Now the way it works is when you click on a sign, the click events are ran from line 1, then line 2, then line 3, then line 4. Yes, another thing I had to test to see if it worked. They're always ran in that order. So it allowed me to first set a variable corresponding to the slot that had been clicked, and then run that. So that's it, pretty much. Now if you're wondering how this is supposed to be viewed, the normal default viewing position would be like that. And yes, you have to move around, but this is the best spot for being able to look at and reach the signs. And there will be a link to the world download in the description if you just want to mess around, possibly incorporate this into your own map. If you do, please give me credit. I'm very proud of this system. It did take a little while to figure this all out. I'm not going to say it wasn't easy, because I did build this from scratch today. In, like, 5 hours. It's been 5 hours about 5 hours since I've started building this. But it is somewhat complicated, and credit would be very appreciated. I wish I could say required, but since it's going to be public, that's not really something I can do unless I actually get it licensed under some, like, Creative Commons or something. I don't know. I'm not really too into that. I'm content with knowing that you probably won't even be able to understand how it works. Hardly. Most people can't understand the stuff I do. Until then, have fun moving your names around. If you do manage to figure it out, please tell me, because you'll be one of the first people to do it. But until next time, this has been Friar Emerald with my infinite data storage system. Man, it's so great. Bye.